Hello and welcome, my name's Ryan, I'm also known as RM2K Dev. In the last video, we set our server up to deal with the user model so that we can actually save our characters into the database. In this video, we're going to be creating the login section of our application. So this is going to start on the client side and then we'll move over to the server side when we can actually save the data into the database and deal with the login packets. So since we've already set up our UI, this is going to be a fairly straightforward section of the tutorial. We first need to create a function to deal with writing information to the network. Now, if you remember back to our handle packet function, the network event inside of our sockets system, we were talking about making the first byte of our packet the size of the packet so the server is able to dissect any packets that have collided together and deal with them one by one. We need to do the same thing on information that we send back to the server. The reason for this is the server is going to be dealing with a lot more data than the client side was dealing with, and there's a much higher chance that packets are going to collide together and arrive at the server software 2 or 3, even 4 or 5 at a time. If you're running a game that has 100 players online on one map and they're all moving around at the same time, we could expect to see that this packet collision happens very frequently. So we need to write a function that we can pass a buffer of data into that will calculate the size of that data and also append the size of that data to the start of the packet. So let's begin by creating a new script. I'm going to call this script network underscore write. Now that's obviously so that we can write information to the network. Sorry about that, my chair is a bit squeaky. So I've just called my script network write. I will click the save button so that that appears on the side, and I'll just open it up again. So the first argument to this function is going to be the socket that we're going to write the information to. So argument 0 will be socket. Argument 1 will be the buffer of data to send. And now we can initialize. There we go. So first of all, we need to create a variable to store the packet size. So var packet size is equal to buffer tell, and that's going to be argument 1. So buffer tell is going to tell us where we're currently at in the read position of a buffer. Now, because all the packets that we send to this function will be created before we send them, the reading position of the buffer will be the last byte. So this will tell us the size of the buffer. Then we need to say we need to create a buffer that we can start appending information to. So I'm going to say buff packet, and that's going to be equal to buffer underscore create. It will be of a size of 1, type buffer grow so that it can expand, buffer grow, and it's going to be aligned to 1 byte. Then we're going to write the size and the packet into this new buffer. So I'm going to make a comment, write the size and the packet into new buffer. So we can do this using buffer write, so buffer underscore write. We're going to write into buff packet. It is going to be a unsigned 8-bit integer, so buffer underscore u8, and this is going to be the size packet, so we're going to say packet size plus 1. Now, just like we did in the server side of things, we're going to add 1 byte to the packet so that we don't just have the size of the information we want to send, we have the size of the information we want to send plus an extra byte for the size of the information packet, which is of the size of the information that we want to send. If that made sense. I hope it did. The next thing that we want to write is the actual packet that we supplied to this function after we've written the size packet. So buffer underscore write, we need to write argument 1 into, that's going to be type 0, just nothing. I don't actually know what type 0 resolves to, but it works. And it's going to be the size of, not buffer write, buffer copy. Buffer copy. Sorry, I've lost my mind today. So the buffer that we want to copy from is argument 1. We want to copy from the beginning of that buffer. It's going to copy the packet size, so that's the size of the buffer. And we're going to copy that into the buff packet. And it's going to be offset by 1 byte because the first byte that we wrote above it was the size of the packet. And finally, we can seek to the end of the buff packet so that we are at the final byte of the packet before we start sending it to the server. So I'm just going to say buffer seek. This is going to move our pointer in the buffer to the end. Buff packet. The base is going to be 0. And the offset is going to be packet size plus 1. Now we can send the packet to the server. So I'm going to write send the packet. In here, we can just say network send raw. This is going to take 3 parameters. The first being the socket. Well, we supplied the socket to this function in argument 0. So that will be argument 0. The buffer that we want to write to the server is going to be buff packet. And the size is going to be buffer underscore tell buff packet. There we go. Finally, we can get rid of the buffers, because once you're done with the buffer, you always want to delete it so you don't have buffers just sitting in memory. I don't think they're garbage collected for you automatically inside of GameMaker, so you have to deal with them yourself. So destroy the buffers. So we've finished with the information, and now we're just cleaning up after ourselves. So buffer, just delete, and we're going to delete argument 1 first. Argument 1. This is just so that we don't have to delete the buffers every time we create them to send a packet. And the next one we're going to delete is buff packet. So now we've created a packet, we've filled it with information, we send that packet to the server, and then we get rid of it. And we also get rid of the packet that we supplied to this function. That's just so that we don't have to do this in every other place that we make a buffer that we send across the network. Okay. So hopefully all of that made sense. The next part is to actually start working on our user interface side of things. So I'm going to jump into my room-specific objects under the login folder, and I'm going to go to the btn login button that we created earlier. I'm also going to open up my sample code just so that I have a reference. Okay, so in our code event for btn login.left released, we can first of all inherit the event. This is so that our parent will execute its own left click event in case we add some sort of logic to our UI framework later down the track. And now we can do some validation to see whether or not the user has supplied information to the client. So if string underscore length txt underscore username dot text. So if the user has supplied, if string length txt username dot text is greater than 0, so if the user has typed something into the username field, we will accept that as valid. And string length txt underscore password dot text is greater than 0. So if the username and password both have characters in them, we're going to accept that as valid. So if both of those conditions are met, then we will execute this. If they're not both met, we will show a message, or you can use a toast or whatever you use in your game. I'm just going to use the alert function for this. Error, username or I hope if I can spell. Username or password cannot be blank. And I will also not capitalize every word in the sentence. Now, before we add any network programming to this or network code, I'm just going to start up an instance of my server by hitting the play button just to make sure that it's running. There we go, my server's running. And I will also start up an instance of our client to make sure that our validation functions are working. So the client's working. I'm going to type in I'll press login. It says that cannot be blank. If I type something into password and press login, username cannot be blank. And if I type something into both of them, I press login, nothing happens because that was successful. And of course, if both of these are empty, that is invalid as well. Perfect. So where it says execute this, we can now begin to compose our login packet. So I'm going to say var login underscore packet equals buffer underscore create. It's going to be of size 1, of type buffer grow, so that it can expand as we add data to it, and it will be aligned to 1 byte. Now, if you remember back to some of our earlier videos where we talked about our packet format, it was size, command, and then properties. So the first piece of information that we need to write into our packet is going to be the command. So I'm going to say buffer underscore write. The buffer that we're going to supply this to is the login underscore packet. The type is going to be buffer string because we're going to write a string value into this buffer. And the string is going to say login, and that will be our command. The next thing we need to write into the buffer is also going to be a string, so I'm just going to copy paste this 3 times because we need to write the username and password in here. So the second value will be the username. So txt underscore username dot text. And finally, the third value that we write is txt underscore password dot text. So now we've created our login packet, we can use the function that we created earlier, network write, to send that to the server. So if I say network underscore write, now remembering that takes the socket as the first parameter. Well, thankfully, we have set up the socket inside of our network object, which is persistent, and it was created on the first map of our game, where the server initializes, where the client initializes its connection and all of the variables that it needs to deal with data that's coming from then on. And in that create event, we created the socket. So that socket will exist in global scope now forever. So the first parameter to our function will be network.socket. The second parameter to our network write script that we just created was the buffer of data that we wish to send to the server, and that's going to be login underscore packet. Now, if you remember back to the script that we just wrote, the network write script, the last thing it does is destroys argument 1. Well, argument 1 is the buffer that we created inside of the login event here. So you don't have to worry about cleaning this up anymore. You can just create the packet, send it to the server, and the script will take care of deleting that buffer when it's been successfully used. So now our client side is done. Let's jump back to the server and start implementing the login packet packet model, I suppose. So the first thing we'll need is a packet model to compare this to. So back in our initializers, I'm going to create a new JavaScript file. This one's going to be called 00 because we want this to load before the database loads. So this is going to be 00 packet model. Packet models with an S, .js. Now inside of packet models, we're going to use a library called binary parser that we included in our package.json file. So that should be in your folder here now. Sorry, not performance now, binary parser. So I'm going to say var parser, that's P-A-R-S-E-R, parser, equals require, and we're going to load in binary dash parser. Now this one here returns us I don't actually know what it returns us. Whatever it returns us, it's exporting a variable called parser. So we need to say .parser. The next thing we need to know is that GameMaker, I think I explained this before, but GameMaker has a, not an interesting way, it has a very standard way of sending a string. The string will be a bunch of hex values. So for instance, make a comment. So FF, F0, E7, AA, B, C, whatever. And then when your string is completed, it ends it with 00. So this is called a zero terminated string. So we need to define some string options so that our parser can actually deal with and understand zero terminated strings. So I'm going to say var string options. It's going to be equal to a JSON object. Length is going to be defaulted to 99 characters. And we're going to set a value called zero terminated to be true. Now this is just going to be some JSON. The only reason we've defined this here is so that we don't have to define it many times across our application where we use it in multiple places. We're going to be able to just take it and use it straight on the parser object without having to retype this all over our application. So now we need to export a packet model from our packet models file. So I'm going to say module.exports equals packet models equals and then a JSON object. So if you remember back, I've said that about 8 times, I think, in this video now. But if you remember back to some of the earlier videos where I talked about the packet format, everything starts with a size variable, and then it starts with a command. Now, the size variable is always going to be 1 byte. So the first thing we need to do is figure out which command, which command is coming in. So we'll do that by comparing the incoming packet against a header packet, which will be the size and the command. So I'm going to say header, that's going to be equal to a new instance of parser. And the first thing that it's going to do is skip 1 byte, because the first byte is just going to be an arbitrary number telling us how big the packet is. And at this point, we don't really need to worry about that. The second parameter that we'll pass to that is going to be a string. So I'm going to type .string, and we're going to name this string command. We're also going to give that string the string options so that it knows that it will not be greater than 99 characters long, and it will also end with a 00 in hexadecimal value. And that will be it for our packet models for now. So now we need to make sure our game actually can deal with and understands this packet models file. So back in our, I believe it is server.js. No, sorry, it's not server.js. It will be, hang on 1 second, I'll tell you in a sec. Sorry, forget what I just said. It's an initializer, so it loads up for us automatically at the start of the application. So we can now go into our packet.js file, where we will begin to deal with the packet that's coming back from the server. So this is where we create our first function, which is going to be called parse. So we've got this build method up here, which builds a packet for us. Now we need to create a new function called parse. And this is going to be of type function. It's going to take a client in as a parameter. And it's also going to take a string of, sorry, not a string, it's also going to take a buffer of data that needs to be passed. I'm just going to add a comment to this to sort of serve as some indication to what's happening. Parse information, sorry, parse a packet to be handled for a client. There we go. So in our parse function, as I mentioned about 1,000,000 times, we need to deal with the fact that packets will collide with each other. We'll end up with, say, packet 1 and packet 2 and packet 3 all strung together in one big string. However, we were awesome enough to define the fact that the beginning of our packet starts with the size of the packet. So we should be able to split these up just like we did on the client side. To do that on the server side, we're going to start by saying var IDX equals 0, that just stands for index, and I'm going to be using this as the index in the buffer. The next thing I'm going to do is say while IDX is less than data.length, so while the index is is not as big as the size of the data, which means we have not traversed through the entire chunk of data yet, we can first of all extract the first byte to find out how big the packet is going to be. So var packet size equals data.read. We're going to read an unsigned int, and it's going to be 8 bytes as we supplied it from the client. We're going to read this byte at the position of IDX, so the index, which will start off and will be 0. So all packets start with the size of the data, so the first byte that we get from a client will always contain the data size, the data size. Then we can extract the packet. So we can say var extracted packet equals new buffer, and it's going to be the size of packet size. So we're just setting up a place to store the packet now. Finally, we can copy data.copy into the extracted packet at position 0 from IDX, which is the index of the current packet, to IDX plus packet size. So basically we're saying, let me make a small example here. If I had 0s, 1s, 2s, and 3s, and we wanted to split this up, let's just for instance say that X represented the size of each of those packets. And really they should be like this. They should be something like that. That's how we want to process them. We want to process them one at a time, okay? Let me just undo that. So what this function does is it starts at the first byte, and that's IDX 0. it reads it, and IDX now, it reads it into packet size. And that now says, I don't know, how big was that? 1, 2, 3, 4, 5. So that will be 5. So that's going to say 5. So it reads the first byte, which says 5. Then it creates a new buffer, which is going to be 5 bytes in length. So it's enough for that. Well, I think it will say 6 actually, including itself. So it'll be 6 bytes in length. Then it copies that data from copies that data into extracted packet at position 0. So currently extracted packet contains nothing, and IDX is 0. So IDX is 0 plus 6, 1, 2, 3, 4, 5, 6, including itself. It copies that and puts that into extracted packet. Then what we need to say is IDX plus equals packet size at the very end of our while loop here. So what's happened is IDX was 0 originally. It was 0. Then it moved across and now it is 6. So if we keep this in here, we've only made a copy of it. We now go to position 6 and we do the same thing because it's in a while loop. So it loops over again and now it goes to position 6. It reads X, which says 6 as well because there's 1, 2, 3, 4, 5 ones and the 6th bit is itself. Then it goes from position 6, we're going to copy out the next 6 bytes, copies them out into extracted packet, and increases IDX by the size of the packet, which was 6. So 6 and 6 is 12. So then we move on to position 12, and we continue doing that until we have successfully looped through this entire string of data and processed all of these packets. Hopefully that made sense. If it didn't, then I'm sorry. So now that we have the extracted packet and it is just one packet, it's not multiple packets collided together anymore, we can say this dot interpret. We're going to pass the client into the interpret function, and we're also going to pass the extracted packet into the interpret function. So pass was really just to take the incoming string of data and split it up into as many packets as it needs to be split into. Now we need to create a function called interpret. So I'm going to say interpret is equal to function, takes a client and a data packet. Now in our interpret function, we are going to start dealing with what the packet is and what do we do with that packet. So the first thing we need to do is compare the data packet against the header to find out what the command was. Because if you remember back to our packet models, the header will tell us what the command is. So what I'm going to say is var header is equal to packet models dot header, because that's the packet that we want to compare against, dot pass, and we're going to use the data packet as the data that we supply to that. So what this is going to do is it will take the data packet, compare it against header, and header will tell us what the command is by skipping 1 byte and reading the first string, which will always be the command of our packet. At which time we can simply say something to let us know that things are happening. Console.log interpret, and I'll just say plus header.command. And binary parser is a really awesome library that basically allows us to compare this binary data together and puts that information onto an object for us to use. So .command is coming from the fact that we declared command. If we called this QQRRZZ, it would come out as that. So back in our packet.js file, we can now begin to deal with the packets. So I'm going to use a switch case statement for this. So I'm going to say switch, and we're going to be switching on header.command.to uppercase. Now basically we're going to use 2 uppercase so that it doesn't matter what case we send the packets in, we're always going to be able to figure out what it is. For the first packet, this doesn't really matter because you'll never actually display this to the client. So in the case that it was login in capitals, because it's in uppercase, we will do something and then we will end. And in the case that it was register, we will do something and then we will end. Okay, so I'm just going to add do something. So this is how we deal with packets. the packet will come into the parse function. It gets extracted into an individual packet. That individual packet gets sent into the interpret function, which compares the packet against the header. And then based on what the header was, if it was a login, a register, a position packet, we will do something. So for our login packet, which we're going to be doing in this video, I will say var data equals packet models. So we're going to do the same thing here. Dot login dot parse, and I'm going to pass that the data packet again. So we've established what the header is. Now we need to figure out what the rest of the packet is. Now we don't have a login packet in our packet models yet, so let's jump back to packetmodels.js and add one. So just below our header command, I'm going to add another command called login. This is going to be a new instance of Parser. It is also going to skip 1 byte because the packet hasn't changed. We haven't removed this information. So it needs to skip 1 byte. It also needs to contain, skip 1 byte, a string for command. Oops, got some formatting issues here. There we go. The next thing it needs to contain is 2 more strings, because the next 2 parameters were the username and the password. So the second parameter is going to be username, and the third parameter is going to be password. Now, obviously, in your game, you should be encrypting this data. I'm sorry, I don't need the commas on the end there. You should be encrypting the password at least before you transmit it across the network and decrypting it on the server side. So you should never ever store the user's password in plain text. I'm simply doing that just to show you guys how to get this up and running. It's totally up to you to implement your own security in your games. So what I would suggest doing on your client side, before sending the text password.txt, you run that through some kind of cryptography library in GameMaker, whether that be an MD5 string or a SHA, I can't remember what they're called, a DES string or something like that, to convert it from plain text into some sort of hash that represents the text that you want to save. Then if you compare the two hashes together rather than the 2 passwords, you'll have the same result. So now we have a login packet defined. I'm going to jump back into our packet.js file in our login function, where we now have packetmodels.login.parse. Now data should contain username and password. Now we can use that user model that we created earlier to actually check if the login was successful. So if I say user.login, because if you remember back to our models user function, we have this login attached to the user object, and we don't need an instance of a user to actually call it. We can just say user.login. That's what Mongoose has done for us. So we're going to say user.login. The first parameter was the username, so data.username. Second parameter was the password, data.password. And the third parameter was a function to deal with the callback, so function. And if you remember correctly, we passed in the result of the login, whether it was successful or failure, and the user. So I'm going to say result and user as our 2 parameters. Now that we've queried the user object to check if the login is successful, we can deal with that at the login packet phase. So we can say if result, so basically if result was true, then that means the login was successful. Otherwise, the login was unsuccessful. So I'm going to say c.socket, since C is a client and a client has a socket, and we can write to that socket. I'm going to write the result of packet.build, because we need to build a new packet to the server, and the packet is going to be login, and the second parameter is going to be a string that just says false, so that the client will know that the login failed. Now, if the login was successful, what we can do here, which is getting kind of interesting, since we have a user object, since we have a client and we have a user object, we can actually attach that user to the client. Now, by dynamically attaching the user object to the client at runtime in our login function, what we've essentially established here is the fact that the client will contain a user object if the client was logged into the game. And we've also created a way that we can access the current socket's client data, so we know who the current client is, because a socket doesn't actually tell you who someone is. But by storing the user object onto the client object, we will know who that client is. So I can simply say something along the lines of, let me just get rid of all this white space. c.user equals user, and that is the user that was returned to us from the database and from our login function. Finally, we can call a function to say c.enterRoom, which we will create in just a moment. And the room that we're going to enter is c.user.currentRoom, and that is because the user object knows about its own room, knows what room it's currently in. The next thing we're going to do is c.socket.write. So we're going to send some data back to that client or back to that socket, and it's going to be the result of packet.build, or as always. And this time we're going to send across a login packet. It's going to be the same header, and the result this time is going to be true. The login was successful. And we're also going to send in a little bit of metadata so that the client knows who it is, where it's going, where it is. So we're going to say c.user.currentRoom so that our GameMaker client can pull that information out and send the user to the right room. c.user.pos_x, which is your X position. c.user.pos_y, which is our Y position. And finally, c.user.username, which is the username of the account, so that we can display the user's text above their head. And that will pretty much do it for our login function. However, we're not going to be able to log in until we can register. However, this video has gotten to about 30 minutes long, so I think I'm going to end this one here, and we will begin on register in the next video. So thank you guys for watching. Don't forget to like the video and share it. And yeah, in the next video when we do register, we might have some bugs because it has been a lot of code that we've written, but we haven't tested it yet. So we're going to have to write the client side for register and the server side for register, and then we'll have to do a quick test to make sure it all works. And I presume there might be 1 or 2 bugs when we run the application, so we'll see what they are and we'll fix them as they happen. So once again, thank you guys for watching. Don't forget to like, subscribe, and leave any comments and feedback in the comment section below. Bye guys.